Good day, everyone. I'm sorry I can't be with you there in person, so I'm afraid this will have to do as my contribution to Oz KFest 2017. Some of you may have met me at Kansas Fest back some time ago when I was there. Some of you may have met me in other ways online, and some of you may simply have just used my software. At least I hope all of you have done that. What I'm going to talk today about is how the internet works under the surface. These are the bits of the internet you don't see, but which the software actually makes happen what you want it to do. Let's give a little background here. Mankind has been trying to communicate with each other right from the very beginning of time. I suppose the first instance was trying to tell his fellow hunter where the best bit of meat could be found. But eventually all kinds of other bits of information were being transmitted. To start with, all we had were our voices, and we could speak to each other directly and communicate our thoughts and what we wanted to say. That wasn't very good for distances, so we perhaps invented machines to make it easier to hear from a distance. At some point later on, we got printed word, which allowed more complicated thoughts to be presented, or greater amounts of information to be transmitted. That wasn't terribly good for sending for a distance, because you had to package up the newspaper or the book and transport it by either carriage or horse to get from point A to point B. So then we got into the realms of electricity, and that made possible things like the telegraph, using Morse code, and you heard some Morse code at the beginning, and anybody who understands Morse code will have worked out what it said. Then we got the telephone once Alexander Graham Bell invented that, and that really shrunk the world down to a very small size. And to this day, the telephone in one sense still remains the largest connected instrument there is in the whole world. Computers came along, of course, and we wanted those to talk to each other. And the only way we could do it initially was with things like this, with acoustic modems. And that shrunk the world even further. More information could be transmitted more easily. But that wasn't fast enough. So then we got to the modem like this. And I had one of these running a bulletin board for many years. And this really was the pinnacle of transmission until the internet came along in its wake and killed off the modems essentially very quickly. But all of that involved wires, and you got to the state where some cities might look like this, with a massive wires connecting every point to the other point. And that was terribly inefficient, and especially if you wanted to transmit over a distance like from one continent to another. And it also, the directed data going from modem to modem wasn't terribly efficient. So we then got a system called ARPANET being developed by the Americans, which was initially for defense purposes, but was quickly latched on by the universities. And they produced a small network which connected all kinds of different points within the United States. And that, of course, has grown into what we know as the internet today. We now use satellite dishes like this to communicate to satellites, which then transmit back down to another country to a similar dish at the other end. And this has made all kinds of things possible. We now get instant television all around the world, so news reports can be direct instead of having to wait for weeks or days to get them through on the older processes. Transmitting data point to point was very inefficient, although using the X and Y and Z modem method of splitting the data up into packets did improve matters considerably. But with ARPANET evolving into the internet, and some preceding methods as well. Everything got broken down into a system of packets. These packets could then be sent by any means possible, by whatever direction or cables or whatever method there was, as long as they all arrived at the other end and could then be reassembled together into the data that it originally started from. To do that, the internet works entirely on packets of data. Millions of these packets are flying around the internet at any one point. It's very simple how they're constructed. A chunk of the packet is purely data, and then there's a header, and the header is the important part, because in the header, as you can see here, there's a source address that says where it's come from, a destination address where you want it to go to, and then another one which says how long for this packet to last. Now that is very important because the packet is sent out and it will go whatever direction it can take, and at each point or each node it will be redirected to where the destination address is. Every time it passes through a node, the time to live is dropped by 1 point, so that eventually, if it never gets to where it's supposed to go, the packet will simply die because it no longer has any life left in it. When a packet does get to destination, it is then acknowledged, and the acknowledgement goes back to the original sender of the packet from the place where it arrived, so that the original sender can then check and see that it actually got there to the other end. The packets have a checksum in as well, so that they can be checked when the receiving end, then if it's not right, can be requested again. That is how the internet works, so that everything that you send, whatever it may be, will be split up into packets and sent out one by one across the internet. Within your local area network, your LAN, a similar system works in that an extra header is put on top, an Ethernet packet header, and this is simply for the local network's purpose. When it gets to your router or your modem and is sent out onto the internet, that Ethernet head is stripped off. And when a packet comes back, another Ethernet header will be added and it will be sent across your LAN to the target computer or target device where the request was originally sent from. We've seen how the data is transferred across the internet by means of packets, but we have to make sure that data gets to the correct destination. Within the TCP/IP packet, as I showed you, there is an IP address. This shows where we want that data to go to. Now, that's all very well, but how do we translate that from the address that we may have been given, such as in the case of Oz KFest, we've got the HTTP Hypertext Transfer Protocol, which is the web method of sending data. And the address we've given is ozkfest.net, but the internet doesn't know about those things. All it knows about is numbers. And initially, we're working with an IP address which has 4 segments. So you see here 98.139.135.129. Now that is the actual address that the internet knows for sending data. So that initial ozkfest.net has to be converted into those numbers. That's all done behind the scenes by a domain name server, which the controlling program will contact and will ask it to translate the English text of ozkfest.net into the numbers that you see there. That's all done within the software on the computer, and in the case of a 2GS, in which I'm using for these demonstrations, that's done by Marinetti. That address is made up of a number of numbers, as you can see, and they work from left to right. So the first one and the first 2 designate wherever ozkfest.net is. Then the next one, 135, that designates further down the chain, and finally 129 points directly at the website where ozkfest.net is hosted. You can see that more clearly here. the number is defined up. This is a different IP address, but it shows how it's split up into the 4 sections. That will get us to the router, or your router, whether it's on your network or whether it's on a public network. And that's all very well, but the router has still got to get it to the destination, which may be one of a number of devices on your LAN. When you called out, the router made a note of which device actually sent out the calling packets to connect to the host that's now returning data. So it then knows that, and it will adjust the packet data so that it points to your device. And that's usually done by the Ethernet header, which it attaches to that packet before it's sent out on the LAN. Now that's all very well. We've now got the packets of data to the actual destination computer or device. That device may be able to do various things. It may be able to show web pages, it may have a mail program, it may have an FTP program, it may do various other things. So we need to specify precisely where it has to go. And that's done by having ports. There are a large number of possible ports, but all the ones that matter are down at the bottom, as you can see in this list. So the process of connecting to another server and establishing communication so that something can happen is done by, first of all, opening a port at the far end. So if you were calling up a web page, you would call the destination website by taking that initial HTTP address, which is in English, asking the domain name server to convert it into an IP address, and then using the IP address, open a port, a web port on the server. And you'll see there that a web port is port 80. The other end will then reply to that request and say, yes, I'm now open, and will send some data back. With that port open, then the packets of data going out have that port listed in them so that any return packets can go correctly to the right computer on your network and also to the right program that actually called up and asked for that information. So that's how everything works on the internet. So we've now got it down to program level, and that I will cover next. We now have our application open, and the data is being transferred back and forth, having opened the ports. But how do we send that data? Here we move away from pure data and we come into English again, because the internet and the actual application or program level works entirely initially by sending plain English commands back and forth. I'm using an example here, SIS, Spectrum Internet Suite, which was written by Jeff Weiss and myself. And what I'll first do is we'll call up and go to the page of the Oz KFest. So here we see I'm typing in the address of ozkfest.net, and then we click the green button, which tells it to go away and actually call up the page. And very shortly, here we have the page. Now this looks very odd to us because this is all we can do in a 2GS or have been able to do so far, but links are shown in yellow and underlined, for instance. But that is the web page you get back when you go to ozkfest.net. So we'll now look and see how we actually did that. And this is the actual transcript of what went on, with the commands that were sent out, requesting the page, the response that we received back, and then the data itself. I've truncated the data here simply because there's no point in showing it all. So let's start at the top. Here we have the command that was first sent out. Having opened the port, we sent out the command get index.html. Now index.html is the actual web page that we want, because all initial web pages on websites are nearly always called index.html. And then we put after that http /1.1 to designate that is the kind of HTTP or web data that we can handle. Below that, there is user agent Mozilla 2 compatible sys 1.22gs, and that simply means that the user agent or the program we're using, the application sys, is compatible with the Mozilla 2 and that we are running it from a sys 1.2 application on an Apple IIgs. Below that is the host we're going to, Oz KFest.net, and then there's a pragma accept, and these are just simply instructions for the other end to send normal plain English HTML back. As soon as that connection was made, we then got a response from the other end, and there we are, there's the response, and there's a whole lot of information in there, but basically that's saying, yep, we've got you, we're all connected, we're all ready, we're able to go, and this is what we'll do. And as we've requested the page, it then immediately sends after that the data itself. And that's headed with doc.html, and those familiar with HTML will understand that language there. Now you see a space after each section. So when the command was sent, there was a double return line feed set sent out, which is saying that's the end of our instruction. And then back we get a response. At the end of that is again, there's a double space and return saying that's the end of that bit. And then we get the data itself, and that will be terminated again by a double space and return, or double return at the end. So that's how we get a web page back, and you'll see it's all done in plain English, but that of course is then split up into data and sent over the network as data. Sending and receiving mail is very similar to retrieving a web page, but there are some differences, and you'll see a lot more is involved in talking to the server to retrieve or to send a mail. I'm using SAM2 here, which is capable of sending through an SMTP server and retrieving mail through a POP3 server. So first of all, let's show us how SAM actually does it. Here's a sample message, and now we'll queue it so we can send it later, as we might want to send multiple messages. And here we go, we're now going to send the queued messages, and there it is, it's been sent successfully. And now we'll go and see if the message is there. There it is, and now we're going to retrieve it, and it's also deleting it from the server at the same time. That's optional. Now let's see what actually went on. When you connect up, first of all, to a server, as we saw with retrieving a web page, you will get a response coming back. And here you see a response in Aqua, the line there, which has got 220, then smart host, and so on. And this is simply the server saying, this is me, this is the time, I've received you, we're now connected. What I must now do is to log in to the server. So I log in by sending an EHLO command. There is a hello command as well, which can be used, but this one is a bit more, gives a bit more information, and it says, I'm saying hello to you. And then in response, I get back quite a few lines of data here, which again is the server saying, here I am, I recognize you're there, this is the size of messages that I could take, and various other information there, and then finishes off. You'll see all those lines are marked with 250 with a dash and then the command. As soon as you get a line which is 250 or another number and a space, then you know that's the last of the sequence. So there we are. So now I can start up the process, and I'm saying I'm going to send a mail from me. There we are, Speccie at Speccie UK. And in response, I get a 250 OK. 250 says, yes, all's well. The space, OK. So I know that's the last response to come back. So I can now say where I want it to go to. So I'm sending it to, I'm actually sending to the same address, but of course it could be anywhere. And back I get 250 accepted. So that means, yes, it's okay, everything's OK, and it's been accepted. If it wasn't OK, I would get another number than the 250. So I now say, right, it now knows who it's from, where it's going to, And if I'm sending it to a number of people, I can simply put more addresses in there. So now saying, okay, now this is the data I want to send. So I'm saying data, and in response, I get a 354 message which says, yes, go ahead, enter the message and end with a full stop or a stop on a line all by itself. If you actually want to send a stop on its line by itself with an email, you simply send a double stop. This is only for the start of a line. It doesn't matter where else in the line a stop is used. So I then send a whole bunch of information here, which is simply me saying, here we are, this is my message ID, that's unique, and that can be used later, and what MIME version I'm using, what the content of the message is, whether it's HTML, text, and so on. And then the content transfer encoding here is 7-bit, because it's only text I'm sending, ASCII text. Then who it's from, where it's going to. These will all appear within the header of the message when it comes back, and then the subject and so on, and the date. And then I put in red here the actual content of the message. If you remember, you saw on screen, that was the actual data within the message, which is all that will normally show at the other end. And the server then says back, yes, that's okay, that's fine. Here's an ID we've used, so you can keep that and refer to that later if you want. Then finally, I quit from the server. So that's the message sent out. Now we need to get it back again. So a similar process, we must log into the POP3 server in this case. It's a different port number. And when we log in, we then get the message back saying, okay, yes, we're ready. Go ahead, do whatever you want to do. So I need to log in, because in reading mail, you will need always to log in. So here we are, I'm a user, I give my ID that the server knows me by, and then it comes back and says, that's okay, but please enter your pass with the pass command. So I send pass, and I've asterisked the password here, of course, and then back it says, okay, that's all right, you're logged in. Now I want to know if there's any email waiting for me. So I type a stat command, that's sent out, and it comes back and says, yes, that's okay, we've got 1 out of 3,954 messages. So I say, okay, well, if there's only 1 there, let's retrieve it. So retrieve 1, RTR1 is retrieve 1. And they come back saying, okay, message follows, and then there's a blank line, which signifies that what then comes next is the actual message itself. But what I get is the header first, and that is similar information to I sent out, but there's some other information here as well. It's showing the return path, where it was received from, and so on, and the message ID which I originally sent out, and various other information from there you'll see running down, and the date and so on. And then there's a line space again, blank space again, and so the retrieving program knows that after that space is going to be the body of the message itself. There we are, showing in red again. So there's a full stop, the stop at the end, which is not part of the original message, but is there to signify that's the end of the actual data. And as I've said, if you want to put a dot, a space, a full stop at the start of a line, you would put in 2, send 2 out. So the sending program, if it sees a line with simply a full stop or stop at the start of a line, it will then put out 2 to signify that's what it wants to do. Then, as you saw when I retrieved the message, it deleted it. So I send out the delete message, and that simply says, okay, we've got it now, you can delete it, and so it doesn't take up space in the server. And the server comes back and says, okay, the message has been deleted. And so I say, okay, right, that's enough, I can quit. We saw with both retrieving a web page and sending and receiving emails that we use standard English commands to retrieve the web page or to send or receive the file. FTP transfers work in a similar way. We do, however, open a second port, and this is for the data itself. This means that the data alone comes over that port, and all the data is going to be valid for the file we're receiving, or in the case of sending a file. I'm using Safe2 here and as an example, and now we'll go to Asimov and we'll download a file from there. First of all, navigating the directories. Initially, we need to fill in all the information, and we can use the username anonymous and the password with our email address or an email address, as most of these servers will accept that. So having filled in the information, we'll now click OK, and the download will start. Initially, you'll see it logging into the server, FTP server there, and then up comes the first top menu, second menu, and there's the file we want, mirror list. We'll transfer it. And now it's transferred, we'll disconnect. So let's look at that in detail as we did with the other two. We log into the FTP server, the command port, and there it is. It's come back and said, here we are, we're all connected up, carry on. So we log in with the user anonymous and response, and then password and response, and then we'll ask for what system it's running. This might be useful later on. We come back as a Unix. Now we do CWD, which is change working directory to the top level, the /, and that was successful. And now we want to retrieve the listing for that directory, and we want to list it as ASCII. So we say type A for ASCII, and that will bring 7-bit data across. Now we open this second port, and this is the one where the data will actually be retrieved from. There's two kinds of ports, passive and active. In most use, you'll use passive, and for that we have to ask the server at the other end what is the port number to use, and what is the full IP address, in fact. And so if we do that, we'll see it comes back with passive mode, and those 6 sets of numbers represent the actual IP address of the server and the port that they want us to use. So we open that up, and having opened that up and typed list in the command port, we will then get a response saying yes. And then if we look at the data port, we'll see all that comes back there will be the data itself. And when the data has been sent, that data port will be closed down behind us. And we can then get another response from the command port saying transfer complete. That's brought us to the top level directory. Let's move down. So we saw on the example that the next directory down was pub, so we'll do CWD pub. There we are, and again we'll go through the same process, listing that directory. And that comes back, and that shows us that there is a directory called Apple II. So let's go to that one, CWD Apple II, and the same process. And then rather more data has come back this time, giving a list of files that we could transfer complete again. So let's retrieve one of those files. Now we set it to type I now. This is for data, so that the data will be 8-bit data coming across, not 7-bit data as we had for the directory listings. There it is, it's set to type I. Now we'll see mlist mirror, and now this is simply getting starting a list of what information is in there. And so back it comes, and it gives the information for that file, which could be useful. It gives a full path there. You can see the owner and various other bits of information. And then we'll send out MDTM, and this gets back the time of the file, how old the file was. And that is that number equates down to the actual date that the file was created. Now that could be useful if we're building reference files or synchronizing folders. Then we want to know how big the file is, so we say size. That comes back, and you'll see it's 689, that's 689 bytes. Not a very big one, but ideal for this purpose. And then again, we just open a passive port, and then this time we say retrieve and the name of the file. And that will retrieve that file through the data port we just opened. Now, there's no point in putting the data in there, but showing in red is that the data is received at that point. Transfer complete, and then finally we'll quit, and that's the transfer completed from Asimov. Having seen what we can do with retrieving web pages, sending and receiving mail, and sending and receiving FTP files, I've shown you how it all works behind the scenes. Now it's time for you to try it out for yourself. Many years ago, I wrote a program called Networker, which was designed to simply for exactly that, for programmers and others who are interested to see actually what goes on behind the scenes. Full instructions are given with it, but just here's a quick showing of what it can do. We'll retrieve the web page we retrieved at the very beginning of this session. And so here we are. Here's Networker. And you'll see it split into two parts. This is to allow you to open two ports at once. But we're just going to open one port. But first of all, let me show you the command file we're going to use. Some of this you may be familiar with from the commands that were sent out to retrieve a web page. You'll see the same wording in there, and this is all being put into a macro. So we'll now go and send that macro, and the first part of that macro will actually just open the port to Oz KFest. And you'll see traffic lights at the top right changes to green. That means we're actually connected to them. The port's been opened. Now the second part will send all the information. And you can see a large amount of data has suddenly appeared into that window. And so let's look at that window and see the contents. And there is the data from the web page there. But if I go up to the top, you will see there the actual commands that were sent out. And that was similar to what you saw earlier. And there's the data from the web page itself. Okay, so having seen that, anybody can do that. You just simply follow the instructions, fill in your data, and you can open a port to anywhere you like, see what kind of responses you get back, and use that as information to help you program. Well, thank you for listening to my talk. I hope it was informative and that some of you discovered some new information that you perhaps didn't know, and it may encourage some of you to actually sit down and write a client which could actually access the internet and do what I've done over the years. There's plenty of scope for it, and we would love to have a decent web browser. The one that Jeff and I did back in 96, 97 is getting a bit old these days. So I hope you enjoyed the talk, and there we go. That's me. Goodbye, and goodbye from the UK.